Hello everyone, my name is Rani. I am studying at Institute of Aeronautical Engineering of BTech second year CSC. So today I am going to give presentation on Hans Peter Luhn and the birth of hashing algorithm. So actually Hans Peter Luhn is a scientist who developed the hashing algorithm. So my topic contents are introduction, scientist Hans Peter Luhn, birth of hashing, types of hashing algorithms, and hashing algorithms used for, and the last one is conclusion. So the introduction contains about how Hans Peter Luhn invented it and how what is mean by hashing algorithm. So let's see. Hans Peter Luhn invented hashing as we seen right now. He was a conscientious scientist in IBM researching the field of computer science and information science. A hashing algorithm is a mathematical function that grabs data and makes it unreadable. It's nothing but making the text, combining the text with the mathematical functions and making it unreadable, undecodable. Means the person can't read it's used for keeping the secret, keeping passing the information of secret. And hashing algorithm are one-way programs, so the text can't be unscrambled and decoded by anyone else, as I said before, and that's the point. Hashing protects data at rest. So even if someone gains access to a server, the items stored there remain unreadable. So let's see Hans Peter in his history and how he invented. What's the idea behind inventing the hashing algorithm? Lune was born in Barman, Germany, on July 1st, 1896. After he completed secondary school, Lune moved to Switzerland to learn the printing trade so he could join the family business. His career in printing was halted by his service as a communication officer in the German army during World War I. Lune spent greater and greater amounts of time on the problems of information retrieval and storage faced by libraries and documentation centers, and pioneered the use of data processing equipment in resolving these problems. Lynn was the first or among the first to work out many of basic techniques now commonplace in information science. These techniques include full text processing, hash codes, keywords in context, indexing, auto-indexing, automatic abstracting, and the concept of selective dissemination of information. Loon was a pioneer in hashing code in 1953. He suggested putting information into buckets in order to speed up search. He did not only consider handling numbers more efficiently, he was applying his concepts to text as well. Loon's methods were improved by computer scientists decades after his invention. Today, last hashing algorithms are essential for many applications such as textual tools, cloud services, data intensive research, and cryptography, among numerous other uses. So, actually, cryptography is nothing but hiding the important data and uh, protecting the information. Protecting the information in such it contains the process of protecting the data from third party persons. It is surprising that his name and contribution to information handling are largely forgotten. So, birth of hashing. So, what's the idea behind hashing algorithm? Why he get that idea of creating the hashing algorithm? Let's see. In early 1953, Lund had written an internal IBM memo in which he suggested putting information into buckets in order to speed up a search. Let's say you wanted to look up a telephone number in a database and find out whom it belonged to. Given the 10 digit numbers, for example, let's take 314159 and 2652. A computer could simply search through the list one number at a time until it found the relevant entry. In a database, millions of numbers so this could take a while. So this makes some disadvantage. Taking the time means only one such can take at a time. So we have to wait until the all database numbers have been searched, have been retrieved, have been searched all. Then after it gives uh, it gives results. Luhn's idea was to assign each entry to a numbered bucket as follows. The phone numbers digits were represented into pairs. In this case, as we taken the example of a telephone number which is 31415926652, right? So in this case, that is 31. We are taking two digits. That is 314159 and the 26 and 52. The pair added were the pair digits were then added together. So as we took pairs, that is 31415926652, we should add that. That is 3 plus 1 4, and 4 plus 1 is 5, and 5 plus 9 is 14, and 2 plus 6 is 8, and 5 plus 2 is 7. So from which a new number was generated consisting of each single digit result, or in the case of double digit result, just the last digit. As we took before the example, we got 4 5 14 8 7. So we should take only one digit. If it is in case of two digits, we should take the last digit. That is 4 is has been single digit, so 4 taken. 5 1 4, so last digit is 4, so let's take 4, and 8 and 7. The original phone number and the name or address corresponding to it would then be put into a bucket labeled 45487. So the data of that number, the information of that telephone number, it may be the name, address, phone number, in such a way the information related to it is has been kept in the bucket labeled 45487. Now, looking up an entry from a phone number involved quickly calculating the bucket number using Lund's method and then retrieving the information from that bucket. As we discussed, let's say again, if there is a phone directory number which is what 314159265 we should just add two digits. There are 10 digits, right? We should just add two digits, that is 3141592652. Then adding that number, we get a digit, that is 451487. So in the case of two digits, we should take the last one. So as we get 45487. So this has been taken as a bucket label, right? And this would help the should help to get the number easily without taking much time as we did it before. Before searching for a number in the database, millions of number will be there, so that will be like a time taking consuming process. So this has been replaced by using this algorithm which is created by Lund's method. Even if each bucket contained multiple entries, sequentially searching through a single bucket was much faster than searching the entire list. So this has been very useful when we compare with the previous method, right? Over the decades, computer scientists and programmers have improved on Lund's methods and pushed them to new uses. So by modifying the Lund's methods, they have been created a new process, new new technologies which are very useful. So but the basic idea is still the same, but the ideology is same, but the process of using it is different. Use a math problem to organize data into easily searchable buckets. So it's just used in math function, just adding those numbers, taking 10 digits, like a phone number will be 10 digits, just adding the two digits and getting that, and keeping the number as label, and all the informations and address of that particular phone director has been kept in that label, which will be easily searched by the anyone, by the telephone directory to get the information. So this has been easily resolved the problem. So this process has been very useful, and it's less time consuming as we compare to previous one. So here is the picture of scientist Hans Peter Lund, and how a hashing algorithm works. As I said before, hashing algorithm is just nothing but make taking the just making the text which is unreadable, undecodable, by just applying some mathematical functions. As we see in the picture, we see plain text string, just adding some mathematical expressions. A hashing algorithm means hashing algorithm is nothing but adding some mathematical expressions, just mixing with them and making it unreadable, making it hash and text. Next slide is types of hashing algorithm. Dozens of different hashing algorithms exist and they all work a little differently, but in each one people type in data and the program alters it to a different form. There are different types of hashing algorithms, but people type in data means there's a different ways to use the mathematical expressions to convert into unreadable decoded form. All hashing algorithms are means different types of hashing algorithms are mathematical, uniform, consistent, one way. Mathematical. Strict rules underlie the work on algorithm does, and those rules can't be broken or adjusted. It's just nothing but the giving the rules which is not been breakable, which is unbreakable. It must have to follow the algorithm, and going through it, it should protect the data. It should not be used by any third party person. Uniform. Choose one type of hashing algorithm and data of any character count put through the system will emerge at a length predetermined by the program. Consistent. The algorithm does just one thing, compress data and nothing else. It means just doing one thing, nothing else in such a way. And one way. Once transformed by the algorithm, it's nearly impossible to revert the data to its original state. So as we just discussed, the data is just mixed with the mathematical expression and decoded it, and it can't be get into original state. It should not be it should not be possible to get into the original state. It's important to understand that hashing and encryption are different functions. You might use them in concert with one another, but don't use the terms interchangeably. So, basically, hashing algorithms are used for password storage, digital signature, document management, file management. So, let's see. Password storage. You must keep records of all the username password combination people use to access your resources. But if a hacker gains entry, stealing unprotected data is easy. Hashing ensures that the data is stored in a scrambled state, so it's harder to steal. And in digital signature, a tiny of bit data proves that a note wasn't modified from the time and it leaves a user's outbox and reaches your inbox. Document management. Hashing algorithms can be used to authenticate data. The writer uses a hash to secure the document when it's complete. The hash works a bit like a seal of approval, and a recipient can generate a hash and compare it to the original. If the two are equal, the data is considered genuine. If they don't match, the document has been unchanged. Unchangeable means uh, see, file management. Some companies also use hashes to index data, identify files, and delete duplicates. If a system has thousands of files, using hashes can save a significant amount of time. Popular hashing algorithms. So MD5. This one of the first algorithm to gain widespread approval. It was designed in 1991 and at the time it was considered remarkably secure. Since then, hackers have hackers have discovered how to decode the algorithm, and they can do so in seconds. Most experts feel it's not safe for widespread use since it is so easy to tear apart. And the next one is RIPEMD 160, LibDem 160. The Race Integrity Primitive Evolution Message Digest, or RIPEMD 160, was developed in Belgium in the midst of 1990s. It's considered remarkably secure as hackers haven't quite figured out how to crack it. SHA algorithm in the SHA family, SHA family, are considered slightly more secure. The first versions were developed by the United States government, but other programmers have built on the original framework and made later variations more stringent and harder to break. In general, the number after the letters SHA, the more recent the release and the more complex the program. For example, SHA 3 includes source of randomness in the code, which makes it much more difficult to crack than those that came before. It became a standard hashing algorithm in 2015. For that reason, Whirlpool in 2000 designers created this algorithm based on advanced encryption standard. It's also considered very secure. Conclusion of this presentation is a good hash algorithm should be complex enough such that it does not produce the same hash value from two different inputs. If it does, this is known as hash collision. Means using the two hash should not produce the same inputs, same outputs. It should not produce the same outputs from different inputs. So this is nothing but hash collision. A hash algorithm can only be considered good and acceptable if it can offer a very low chance of collision. Means it should not give a third party or hacker to predict the input, what may be the input and what may be the output. It just gives a it's just protect the data in such a way. And hashing gives a more secure and adjustable method of retrieving data compared to any other data structure. So it's hashing is a more secure and adjustable method of retrieving data compared to any other data structure, and it also protects the data. And it it's it's just makes the hackers to unreadable, unpredictable, what may be the input, what may be the output, how the data is being stored, what the mathematical function has been applied. It's just difficult to hack, to crack the code. So as it is very difficult. And thank you.